environment with an eye towards seeing what sort of positioning is expected here. Okay, so we're going to go to main, go look at the environment. Okay, and once we're in the environment, we're going to go to advanced. And once again, you'll see it's a discrete 2D with a width and height and then rows and columns. So it's a discrete environment. And we have a more neighborhood, so we have four neighbors. Okay. Now, I'd like you to go take a look at the population here. So the population here is going to set the characteristics, the heterogeneity in the underlying population, and specifically it sets the color. So you'll notice it specifies color here. What is this an indication of? What is color, do you think, that it can set it here, associated with the population? Why is it that it appears here, this color? That's an indication that it's a what? You've seen it before. If the population is defining the color for the agents within the population, what does that indicate color is? It's a parameter. It's a parameter of the agent. Remember, parameters are such that when you create the thing that has the parameter, you can specify the value of the parameter. So the main class's populations tells, when it creates the agents within that population, you tell it what expression to use to determine the color for that agent. Similarly, when the main class creates, when the simulation creates main, it specifies the parameters for main. So here, what this is giving is an expression to use to determine the color for each person within this population, this color field. So what is that, can anyone say what does that expression mean? We've seen this random through just about an hour ago. Right. And this is with what percent chance? 50% chance. Yeah. So it's an even flip. Right. So it just flips a coin as to whether someone's initially red or blue. Right? Okay. You'll notice, by the way, this color is a parameter here, even though it is being. The agents are moving here, so their color is not going to be changing. That's a difference from the model we saw earlier. Earlier, we saw a model where the cells had evolving state. Here, we have people, and the people are going to move around. Okay, so let's take this up a level, and let's take a look at the threshold parameter in main. You'll notice there's this parameter here in main called threshold. Who sets that parameter value, do you think, based on what I just commented? Who sets the parameter value here? Yeah. So let's go down to simulation. In simulation here is, go to parameters here. You'll notice threshold is set, for example, to be 0.7. Okay, right there. So here we have the simulation specifying the value of that parameter there. But we're going to look next time, and I'm going to have to divide this up because we don't have time to cover it all. Next time we're going to look at how we build these UI elements, these user interface elements, to set the value of this threshold interactively. And in fact, you see the key elements of it right here. We can actually have it, while we're adjusting it live, adjust the value. Okay, so now I'd like you to open person. That will be a sort of a glimpse for next time. I'd like you to open person, the person class, and I'd like you to go to look at the person's visual representation. Okay, so that's the representation up here. And what you'll find is under the dynamic properties, the fill color is set to be color. So that's just based on that parameter. The parameter that was set, you'll recall, by the enclosing population. Okay, so here what we're going to look at is a discrete time model logic. Okay, so I'd like you to go